Hello, this is Mrs. Taylor, and I'm going to introduce you to the process known as separation of variables. And when we use this process is when we have a differential equation, and remember that just means it's an equation with a derivative in it. And so if we have a differential equation in the form dy over dx equals f of y times g of x, it's called separable. And so what this is saying in notation form is if I have both an x and a y variable together, then I have an implicit equation. And what I want to do is I want to separate the variables so that I can then solve the differential equation, which just means integrate. And so remember, I can only integrate if all my variables are the same. And so what we would do is basically we would move our dx to the right side by multiplying and move our f of y to the left by dividing. And so when we separate the variable, we have 1 over f of y dy equals g of x dx. And because I have the same variables together on the left and the same variables together on the right, I can then integrate. And so we call that solving the differential equation. So the solution is found by anti-differentiating or integrating each side with respect to the isolated variable. Oops, that's misspelled. And so instead of implicitly integrating, I'm going to explicitly integrate by separating the variables. So let's look at an example problem. It says solve for y if dy over dx equals x times y all squared when y equals 1 and x equals 1. And so remember, when we integrate without upper and lower limits of integration, we get a general solution. And so this y equals 1 when x equals 1 information, that's your initial condition, which allows you to solve for c once you integrate. So our first step would be to separate our variables. And the thing to keep in mind is x times y all squared is the same thing as saying x squared times y squared. So the first thing I'm going to do is rewrite it in that form. Don't get this confused when I have x plus y all squared, which we would have to use the FOIL method. Because this is a product, I can distribute this exponent to both of those factors. So then from there I want to separate my variables by taking all my y variables and moving it to the side with dy and moving all my x variables to the side with dx. And so it would be easier just to multiply both sides by dx and then divide both sides by y squared. So when you do that, you get something that looks like this. 1 over y squared dy equals x squared dx. And then from there, to solve the differential equation, I would just integrate both sides individually. So I'll do that next. I integrated with respect to y on the left, and that left me with negative 1 over y, and then integrating with respect to x on the right gives me x cubed over 3. And normally you would put a plus c over here on the left side when you integrate, but what we do with these problems is we only put 1 plus c, because if there had been some constant on this left side, I would have added or subtracted it to combine it with this constant and still have ended up with a constant. So this c represents the constant from both the left and right hand side of the equation. So now I want to solve for c by plugging 1 in for y and 1 in for x, and when I do that I get negative 1 minus 1/3 after plugging 1 in here and subtracting it, and then together that makes negative 4/3, so c equals negative 4/3. And so once I plug that in, I now have my solution. Negative 1 over y equals x cubed over 3 minus 4/3. Now typically what you'll see is that they want you to solve for it explicitly, which means they want you to solve for y. And so for this particular equation, it would probably be easier to solve for y if you treated it like a proportion. So in other words, bring your two fractions here on the right together since they have the same denominator. And so that would make this x cubed minus 4 in the numerator all over 3. And then to solve for y, or to get y by itself, I could just cross multiply. And so I would get y times x cubed minus 4 on the left, and then negative 3 on the right, and then divide by x cubed minus 4. Or you could just think of it as multiplying both sides by y, and then dividing by x cubed minus 4 over 3. Either way, your final answer would be y equals negative 3 over x cubed minus 4. So bottom line is, for the process of separation of variables, it's when we have an implicit differential equation, that is the x and y are together on the same side. What you do is separate your variables, so you move your y's and your dy on one side, your x and your dx on the other, integrate both sides, and then if an initial condition is given, you use it to solve for c, plug that back in, and then you want to get an explicit answer, which means y is solved for. So hopefully tomorrow in class you'll be able to do some of these on your own.